today we are going to be solving Euclid's proposition 14, and his enunciation for proposition 14 says that if with any straight line and at a point on it, two straight lines not lying on the same side make the adjacent angles equal to two right angles, so that the two straight lines will be in a straight line with one another. So we're going to try to prove that line CB and BD is going to be in a straight line with one another. And proposition 14 is a reductio ad absurdum problem, which means that we will be proving it by trying to disprove something else. And so we're going to assume that CB and BD is not the straight line. We're going to be assuming that line CE is the straight line. And that will be our assumption. So we will construct line CE. Our next step would be to show that the angle ABC plus the angle of ABE will be equal to two right angles. And that is because of proposition 13, which says that if you construct a straight line on top of another straight line, it will make the angles equal to two right angles. And so we already know that angle ABC plus angle ABD is equal to two right angles because that was in our given. And so we will say that the angle ABC plus the angle ABE will be equal to the angle of ABC plus the angle of ABD. Because of common notion 1, which says that if two equals are equal to the same thing, then they have to be equal to each other. So you have ABC plus ABE, which is equal to two right angles, and ABC plus ABD, which is also equal to two right angles. So you know that they can be equal to each other. So then you would say that by subtracting the angle ABC from both sides, that the angle of ABE is equal to the angle of ABD. And that is by common notion 3, which says that if equals be subtracted from equals, the remainder will also be equal. But you already know that the angle of ABE is going to be less than the angle of ABD because of common notion 5, which says the whole has to be greater than the part. And so ABD would be our whole, and ABE is only a small part of ABD. And so that would be our contradiction right there. And this is the symbol for finding our contradiction. And so you know that CE is not the straight line. Because of the reductio ad absurdum. And so you know that by doing that, you know that CB and BD must be straight. And that is how Euclid solves proposition 14.